The broadcast is now starting. All attendees are in listen-only mode.
Right, okay, well, welcome everyone to this meeting of the virtual CICS user group. I'm Trevor Eddles, I'm CEO of iTech Ed Limited. We're a mainframe consultancy, analysis and technical authoring organisation, and we're the people responsible for the content on the virtual CICS website, and we produce the newsletters. And if you've got colleagues who work with IMS, then we're also the people who look after the virtual IMS user group. Okay, let me just shut that. Okay, before we start, I'd like to apologise for the last minute cancellation of the November and its rescheduled December meetings. In both cases, it was a speaker who cancelled on us. But, on a positive note, today's speaker is with us, and I'm looking forward to a great presentation today. So, let me start by running through the agenda for this meeting. As usual, most of the meeting will be taken up with the presentation, and today I'm pleased to say our guest presenter is Tom Dunlop. He's CTO at Themis. His presentation is called CICS Db2 Interface. He has sent me a copy of his slides already, and they will be on the website shortly after this presentation ends. And if you've missed any of our previous meetings, you can download copies of those presentations from our website as well, and you can also listen again to the whole presentation. Resources page, you can see those, and many of the newer ones are on YouTube. So, following Tom's presentation and any questions you have for him, we'll move on to the latest CICS news and CICS related articles that are on the internet. Feedback requests is there to remind me to ask you for your feedback about this virtual meeting, and then I'll give you the dates and times for the next couple of meetings. So that's the plan. I'm anticipating that this meeting will last for about an hour and a quarter. Okay, as I just said, today's presentation is from Tom Dunlop. Tom has been working with CICS since its first release in April 1969. Throughout his career with CICS, he's developed applications, worked as a systems programmer and administrator, and lead architect for commercial software products that worked with CICS, and provided both applications and systems level training to many corporations. In fact, his biography goes on much longer than that, so we've got a real expert with us today. So, Tom, I'd like to thank you very much for being with us today. And what I'd like to do now is pass control of the meeting over to you. So let me just do that now. Okay, you should get the same message on your screen.
Okay.
Right, we can see your screen. If you just make your presentation. Brilliant.
Give me a second here to resize again. I love PowerPoint and the fact that it does its own thing and it doesn't remember what I really want it to do. Okay. So I guess we're live, so let's get going here. Thank you, Trevor, for the introduction, and hopefully I'll give you these folks some very good information. Let me get to the first slide. Okay, if you want to jot down my email, please do. I will answer questions myself, no problem. It talks about using a question tab. We do many webinars ourselves, so this is actually on our site also from when I did it the last time. But anyways, if you do have questions, by all means, send me emails. I do answer them, not a problem. So let's jump in because there's an awful lot of stuff to cover, and Trevor said that the PDF should be available shortly after the meeting. You can take good notes, but the slides are more than slides. You'll find that the PDF you're going to pull down has lots of notes in it. So let's kind of move on. So I call this the CICS Db2 interface for all. I'm covering really all bases. So first thing I want to do is take a quick look at this application program that I've kind of put together to help do my testing. So I don't know if I'm dealing with systems folks or applications folks in these webinars, so I cover a little bit of both. But this also gives you a background for the stuff you're going to see later on in trace and statistics and what have you, okay? All right, so my little Db2 program, we have to do some includes. So says Db2. The SQLCA is just communications area that your application is used, and this application happens to work with two tables. So the include of the decal gens for DCL, DCL dep. Yes, these are the standard IBM IVP type tables we use, if you will. Have actually included on the slide one of the smaller decal gens, just so you can get an idea what gets generated, right, by the process of doing the decal gen. So those would be what's getting included, if you will, in your working storages. Speaking in COBOL terms, that's because that's the principal language that applications people have been using. So kind of moving on. So this is going to do a declare cursor. Typically, cursor declares are put into working storage. They're not really executable code. They're more or less executed by another statement I'm going to get to in a moment, if you will. And I always put mine in the working storage. Now, a couple things I want to point out at this point, okay? So when you look at the declare cursor, it's a select statement. Pretty simple one, using one table, emp, and I'm pulling for a particular department, as you can see. So where department number is equal to whatever's been keyed in, okay? So I'm not reading the whole table. So there's a good indication. The old adage we always use is performance of Db2 is 70% the way the SQL is coded, and only 30% that I can influence is the sysatom or DBA. So pretty simple query. But by doing a where clause, I'm selecting certain data. So I'm not processing the whole table. If I have an index by that column, so much the better. Doing something that is going to create a little bit more processing, order by. So I'm ordering by salary descending. Now, chances are we do not have indexes on salaries. Employee numbers, department numbers, common, right? Some kind of key fields. Salary, not so common. So I am going to sort the results. So hopefully the results set is pretty, small. So as you'll read in the notes, a lot of the performance of the query is going to be highly dependent upon the size of that result set, how effective is that where clause, and again, if I'm doing things like order by, where I have to process the results before I can put it out. This is a pretty simple one, okay? But again, it does help me illustrate the things, if you will. So things to keep in mind as we go through. Okay, so getting into the procedure division, I've turned around and did a first select so I could get the average and maximum salary. So this is a little query that's going to show me all the people that work in a department and their salaries, and and a header that would compare to the average and maximum salary, if you will. Okay. Now that is going to have to go through the whole table, where that department number is, I should say. So it's going to pick up all the rows, compute some averages, and that's all it's going to do. Then I do the open cursor. And that's where we get into the issues of how long is that going to take to process? Is it going to build a results set? Does it have to do post-processing like the order by? So it depends, it could take a fair amount of time. And again, you're going to see this in trace, so bear with me. I then fetch, in my application so that I'm getting one row at a time, bringing in all those different columns of data, putting them in, and then eventually I'm going to do a close. So the program, in CICS is in a loop doing fetches for however big the result set is. So it's going to take some amount of time, really depend upon the result set. Now I point this out, one assignment I had to do some performance tuning for a company, and it's been about 2 or 3 years ago. They had 10 cursors in their CICS program. We're talking something that would be better for a batch job because each cursor was taking, about 10 minutes to run. So this online query was running for about 4 to 5 hours in a CICS region. Not a good thing. But I'm trying to give you the mechanics here of things to look at. Okay, so that's my little program. Pretty straightforward, but it allows me to exercise many things about the interface. So let's look at trace. Now, again, you'll get some very good notes. So I've kind of snipped things out. Where you see the solid lines, I've removed trace entries. And if you know about CICS, on the far right-hand side, you can see the sequence numbers, okay? Kind of did this in our little system. Your results are going to vary a little bit. We run 3 CPs, okay? It's a very small little mainframe type system. And I'm running about around 700 to 800 MIPS. So it's not a very fast little system, but it gets the job done. We're just a small developer, if you will. Okay, so what I've kind of shown to you here, and I kind of call your attention to it, on the left-hand side, I got what's called time in the Db2 interface. In trace of CICS, you're always going to see entries and exits. So the very first trace entry I show you is the ERM entry, okay? And that one there is the entry to the interface from my application. You can see COBOL application call to true. So I'm calling the task-related user exit, which is the Db2 interface. The very last trace entry on the bottom of the slide there is the one coming back out, ERM exit. Okay, so I'm coming back out from the call, if you will. And what I've done is computed the time difference. I've kind of bolded the times up there, you can see, on the first and last, and all I've done is subtract the time difference. So 0.01 seconds, essentially, okay? Doesn't sound like a lot, but please remember we're talking about a fairly simple, fairly straightforward, small little query. Again, I'm trying to get to the mechanics, if you will. However, on the right-hand side of the slide, you'll see what I call time in the Db2 region. So you see entry, application request, exec select. So this is doing that select to find the averages. And I kind of documented the time. And then we see the exit. The entries are labeled D2 EX1 and the entry and exit. That's where we're coming back. So again, I took the numbers, you'll see them there in bold, and subtract it out. And you'll notice that most of the time is out in Db2. At the point in time you see those entries, the D2 EX1s, we have actually transitioned to the Db2 address space. Even though we're still running code inside of CICS, the TCB times are being clocked now on Db2 at that point. So that is truly the time in Db2. And if you've ever wondered, am I in Db2, am I in CICS? If you've got these trace entries turned on, you know right away. There's no questions asked. It's still doing things back and forth, if you will, between CICS and Db2, but that range of trace entries is where it's been off into Db2 land doing work, okay? And again, coming back and doing some handshaking, if you will. There's many things that have to go on for an SQL request. So kind of moving on, here's the open cursor. So once again, right-hand side of the slide, we see the ERM events, or the ERM event, the ERM exit. I left off one trace entry, I apologize. And on the right-hand side, we see the DX2, D2EX1s rather, entries and exits were truly off in Db2. So again, didn't take a long time. Now this is the open cursor. So this is the one that actually executed the declare cursor, did the open process, okay, went through, processed all the rows. And I was doing the where clause by department number. So we have an index, so it can navigate through the data fairly quickly. We have a sizable, well-tuned buffer pool. So once retrieved, we're reprocessing out of memory. You know, the first time data is retrieved, you're paying a little bit heavier price because you got to pull it from disk. Once it's in the buffers in memory, it can be retrieved at memory speeds. Okay. Why, as a good sysadmin, I like to keep my buffer pools, you know, where the thresholds are not even being anywhere close to being hit. If I could keep everything in memory, I would. Okay. But that's kind of impossible, especially in some large production sites. So my queries are, my times are actually quite quick because everything is going through memory pretty much at this point. So 0.004 milliseconds, right? 4 milliseconds, 0.004 seconds versus 0.003. So again, you can see that most of the time it's over in Db2 doing real work, if you will. So on the next slide, I captured one of the traces, or one thing for the fetch rather. So again, right-hand or left-hand side, time in the Db2 interface, ERM entry, ERM exit, 0.003, so about 3 milliseconds, about 4 milliseconds actually, 3.8 total time. And then when you look, however, on the right-hand side, much less time, about 1/3 the time in Db2. And this is because we're getting data back. So now the interface has to do a bit more work to save the data, move it into where I told it to put it in my working storage area. So the interface is doing, doing a little bit more work now, right? Taking the data from Db2, pushing it into my working storage, and measuring the results, if you will, okay? So the fetches are running fairly quickly from Db2's point of view, because again, Db2 probably has the buffers totally in memory. So it's a memory-to-memory move, more or less, from the Db2 address space to the CICS address space. This only did 4 fetches, as you can see. So I've recorded the times of all the fetches, okay? You'll kind of notice the first fetch took a while. The second fetch was far less, but then they kind of increased a bit, okay? Total for all the 4 fetches, I simply added it up, if you will. The slight the decrease between the first and second fetch is explainable. We've had to do some more things, handshake, if you will, for the interface, because we're now passing data. Both partners here, CICS and Db2, have to identify each other saying, well, we're reading data, so we may have to do some recovery, okay? So they're putting marks on the wall just in case we start to do some changes or have to do some kind of backouts or commits or whatever. You'll see, okay? Have no great way to explain the slight increase from 2 to 3, 3 to 4, if you will. I'm guessing at this point it has something to do with the fact that we were doing other work over in Db2. I do not have a performance monitor, so I cannot drill down in. I have OmegaMon, I just have not had the time to configure it. But if I had a performance monitor, I could drill down in, to the information that's out there and have pinpointed what's going on. But each fetch is taking slightly longer. I don't have a good explanation as to why. Can explain, from 1 to 2, can explain why that happened, but the slight increase on 2 to 3, 3 to 4, I just have to assume that there's other work going on in Db2, because I'm doing this while I've got my other co-workers, or we're doing classes. So it depends upon what's on our little system, if you will. Finally, my little application is going to do a fetch, or a close rather. So again, left-hand side, total time in the interface, ERM entry to ERM exit, okay, 0.0017. And on the right-hand side, the time in Db2, about half the time, okay? You're gonna kind of see why when I get to another part here, okay? So that's my little application I showed you up front. I did a declare cursor. I did a standard select to get two functions, the average and max salaries. It had to read 4 rows, as you can now tell. It then did the SQL open, right? And you saw the timings there, which basically did a result set because I did the order by, okay? And then 4 fetches, and I just showed you one set of trace entries, but I showed you the 4 different times. I did capture all 4 sets of trace entries. And now the close. So you can see, right, how the interface is going between CICS and Db2. And once again, D2EX1s here that you see in this trace, that's the actual time it's out there in Db2 land. From those two, those pair of trace entries, the entry and exit, it is really being clocked over in Db2. It is actually within the Db2 address space at that point, okay? CICS is still doing events, doing some other processing, okay? But it's really being over in Db2. It's been handed off. Okay. Little different look at trace. So most applications do not do CICS sync point commands. They tend to allow CICS to do it automatically as part of the return. You cannot actually do an SQL commit inside of CICS. Okay, it will work, but it's only going to work with Db2. It's not going to tell CICS anything about it. So I've highlighted the return here, and I've stripped out a whole bunch of trace entries. Okay, and there's some rationale behind it, you'll see. So we're doing a return, and this is at the point where CICS itself is going to say, oh, well, I need to start cleaning up, but I also need to start committing resources. So point number A, and bear with me a second here. I want to take my own PDF a little bit higher. Okay, this is actually in the text, which you'll get eventually. So connector A that you see, and I've drawn the thing together, represents the total time in the Db2 CICS Db2 interface itself. So you see the RMUO entry, commit unit of work. At the very bottom of the slide, you see the RMUO exit, commit OK. Now, if I were to calculate the time differences, you will find out that it's not a huge amount of time. And there's a reason why, you'll see, okay? Then I marked off the range of trace entries B. And this is where you see ERM entry sync point manager. On a mainframe, RRS. Db2 is not transactional, CICS is. And to maintain the coordination between the two different address spaces, both of them have registered with RRS, resource recovery services. Too many acronyms, folks. So the slide, the portion of the trace here that you see for B is the time that has been in RS. So CICS has told RS, hey, we need to do a commit. So RS is now going to communicate to Db2, okay, that the commit needs to happen. However, we still have to have both parties agree. So the range you see listed by C, and again, note D2EX1s. Now we have gone over to Db2. Both sides have agreed to commit, okay? But actually, we didn't have to do that because you'll notice Shortly within the little block of trace entries for C, it says single phase commit. We don't need to really do a two-phase commit for the very simple reason we have not done any updates. Because there have been no updates done on the Db2 side, everything was a select, right? Declare cursor, fetches, in effect, read-only operations, no actual changes. That is why it didn't take very long to do the commit process here, because it is essentially nothing to commit. But if you subtracted the times, 0.0038, right, on the exit trace entry, D2EX1, and you'll notice that the entry is 0.4077, it is still a fair amount of time. Db2 does have to clean up all of the, shall we say, latches it has on the buffers. It still has to put marks on the log to say, we're done with the commit, right? And we're happy.
Tom, I do have a question for you. This is from Jan Mersons, who's, I think when you were on B, put down Db2 is not transactional, and then question mark, question mark, question mark. That must have been on something you said.
Go ahead.
No, but that is
Db2.
Okay. Comment.
Okay. Db2 itself, right, is not a transaction manager. So it is a database manager, right? It is transactional from its own point of view. In other words, it's maintaining its own units of work, okay? But if I have an application that is both Db2 and, let's say, VSAM updates, like my CICS transaction could be, if I did a Db2 commit, it's not going to coordinate with CICS. Okay, so it is not a transaction manager. Okay, it would do the Db2 commit, but CICS would have no idea that you did that. CICS interface is not looking at the actual type of commands that you're doing in Db2 except for maintaining statistics. So that is what I mean by Db2 not being transactional. It's not going to coordinate with anybody else.
Okay, yeah, Jan's come back saying, okay, not a transaction manager, that is true, but it is a transactional system. And then he said, true, that is why we need the CICS, Tran Manager, and RRS.
Correct.
Yeah.
That is why we need that. Yep. And again, MQ is the same way. If I threw MQ into the mix, it would be the same way. MQ and Db2 would both register on behalf of the application with RRS, and RRS would be the coordination point.
Okay, thanks.
You're welcome. Okay, so why I didn't spend a lot of time in commit processing and why I did a single phase commit, because there was no updates. Had there been updates on either side, we would see a two-phase commit. It would say in the trace entries here, two-phase commit, okay? And a bit more handshaking going on. I gleaned out the entries, trace entries here that were pertinent to the processing of the interface. Like I don't show you sending out maps or coordination of free mains for CICS storage and the likes. Okay, so there's your Db2 application in trace, at least from CICS's point of view. I'm a very large proponent of having trace on because it can profile applications. I do tweak trace. When I teach my CICS system classes, I do show people how to tweak trace and get the overhead down. But basically, I'm leaving enough on to be able to profile an application and to solve problems. Okay? It is your best friend, as you can see. And there's no questions. I know exactly where I am by looking at a trace. Okay. So I threw this in, again, because even as systems people, we are going to be working with applications developers, right? And sometimes it's kind of nice to, understand what they see or be able to see what they see and help them out. So CEDF is the CICS debugging transaction that comes with CICS. It's free. I don't have to pay for it, except for CICS. So I've included several of the screens here strictly related to the working with Db2 interface, or working with the actual Db2 commands, if you will. Okay. So about to execute command on this slide, and notice it's the exec SQL select. So this is that first select I showed you where it's trying to pull the average salary, maximum salaries, okay? Note, it tells me my DBRM. That's kind of nice. It tells me the statement number, where I can find it. IVAR is input variable. You know, this is the input department number that I put in. You know, the where clause was predicated on department number. Unfortunately, the CSS has only shown it to me in hex. Charlie 3 is a character C. Fox 0, Fox 1, 0, 1. So department C01, okay? And of course, the standard stuff, you know, as far as PF keys and things like that. So this is about to execute command. So this CEDF debugger will actually stop not only on CSS commands, but on all DB2 statements and MQ calls. If I had MQ calls in here, we would see it stopping on MQ calls. Next slide is actually the completion of the select. So notice again, now it tells me my plan name. Again, statement number, but this time it's showing me part of the SQLCA, that thing I included back there. And the reason that's done is you'll notice the second item in there, SQL code. Zeros is good, it worked, it's happy. Anything else could be potentially an error. Now, positive codes, you know, plus 100, you'll see a little bit later on here, is not really an error. Minus codes are typically bad. So it tells me how it's worked. Now, you'll notice OVAR, so output variable 1, it is a decimal field. So it actually is telling me the type of data, because in DB2 we're reading columns of data back. We don't get records, right? And you'll notice a little plus sign. If I were to expand from there, it's going to give me all of the variables. If you kind of go back, well, you can't, you don't have the PDF yet. But when you get the PDF and look at it, essentially there are two variables coming back. The average salary and the maximum salary. The only two ones coming back. But if I had a statement, a select statement with 10 variables on it, 10 columns of data, I would have 10 different variables. Once again, shown to me in in hexadecimal format, not character. But that little plus sign would allow me to see all the variables if I expand at that point, okay? So it's not a big deal to see all the things. They're just showing us what we can get on the standard Model 2 screen in CICS. So the key things of the SQLC are shown to me. Now, kind of marching on. So now we see the open of the cursor here. Again, DBRM, statement number, and again, this is for the same department, right? C01. Not too much exciting because this is about to do the command. If I move on, command's complete. So once again, SQL code 0, so it worked, no problems. No variables here, right? The SQL open statement really doesn't return anything. It's completed the select, it's built the result set, it's done the sort, okay, as I told it to do on the order by, but it really is not returning anything. That's the purpose of the fetch. So that's why we have no variables here coming back. So now one to the fetch, or one to one of the fetches. So here's about the ready to do the fetch, statement number 498 in my little program, okay? Fetch complete on the very next slide. So now, again, SQL code 0, output variables. Now this one here, as I remember it, there's about a half a dozen columns of data coming back. So if I were to expand at the plus sign there and simply put the cursor there and hit enter, I would see all the variables of data coming back, okay? Again, in hex form. So this is whatever columns I've coded on that select statement, you know, when I did the declare cursor, this is the fetch bringing the data back into my working storage, okay? And as I remember, it's about 6 different columns or 7 different columns coming back at me. Another fetch, However, this is the last one. So I have not saved the screens from all the fetches, only on one of them. So I've gone through 4 different fetches, brought back 4 different sets of data, do one more fetch. This is fetch number 5, and you'll notice it's the plus 100. Very simply, the plus 100 says, hey, I got no more data. Now, do not pay attention to any of the OVARs in this case, because it's the leftover variables from the previous fetch, if you will. I tried to do a fetch and there's just no more data. Db2 is not going to clear out any of this stuff. So it's just the leftover variables, if you will. So this is what your application developers are seeing as they're stepping through their program. And of course, we now see the close in CDF. Okay. And of course, it completed normal, zeros. No variables returned because we're doing the close. Okay. So once again, CEDF, the free little debugger comes with CICS, we can actually see the same kind of thing, the entries and exits, if you will, to all the calls for Db2. And that's what we're seeing. Okay. So now to some real information here. So we've kind of seen my little application and how it appears to both your developers and in trace. So again, don't pay too much attention to the statistics. It's, obviously when I did my little test run, but there's some very important things here. Now, CICS applies a interface transaction DSNC. DISP is the display command for that transaction. There's only 2 or 3 different commands it can do. And then stat is saying, show me the statistics. Now this is the CICS statistics from the interface itself, if you will. And this is not necessarily all of the times or things like that, but very simplistic statistics. Please note at the very top, you can actually see it's telling me the CICS region, TCICS A3 in this case, and the Db2 I'm talking to. Now DB1A in our case, when I put this together, you can see it's been a couple years ago. Just haven't had a need to do it. But DB1A in our case is a version 11 Db2 region. We now are pretty much using Db2 12. In fact, we've got 2 version 11s and 3 version 12 Db2 regions up on our system right now. I also have 2 CICS regions running pretty much most of the time, 2 MQ managers, quite a little bit of, stuff, if you will, technical term called stuff. What we're seeing here is the basic, and we'll see some information coming up about the command, the pool, and then the entry in this case. THMZ ent is my Db2 entry. We'll see some more information about those. But we're seeing the statistics. Command is strictly when I do DSNC transaction, when I do commands to Db2. That's referred to as the command thread. Pool threads I'll get into. It's when you do not have specialized entries, but I'm going to convince you that specialized entries are a good thing. So THMZ ent is my entry definition I've done for my Db2 transactions. Now, what you see is the total number of calls, 7, not many being done. Plan, CICS PL, that's a Db2 thing, right? But I need to have a plan, and my DBAs or sysatoms are going to have to give me the plans. You'll see where they're going to be coming up. Auth is the number of times it had to do Db2 type authorizations. 0 is a good number, okay? It has to do 1 up front, but if I do my entries properly, my authorization should be pretty low, okay? WP is the, shall we say, the plan waits. In other words, I had to do a request and I had to wait for something. Wait or pull flop over, that's what the P stands for. Again, I would rather have my Db2 request wait rather than go over to the pool. I'll kind of explain that in a little bit here. But what's the high water mark for that? Well, 1. Wasn't many people using CICS doing Db2 requests, just me. But the high water mark would represent the number of concurrent requests, right? The high water mark of concurrent requests against the Db2. Again, that's an important number we're going to see. Aborts is how many transactions have aborted. Typically, because I got a Db2 minus 911, some sort, or minus 904s, some sort of contention in Db2, okay? So the Db2 side has rolled back. CICS has to abort the interface, that transaction interface, and roll back in kind. So that's what the aborts is doing. And then we can see the stats on 1-phase or 2-phase commits. And again, I showed you it was a single phase because we had not done any sort of updates. Had I done updates, we would see 2-phase commits. So just a raw count, if you will, entry by entry. Now, in the real world, I'll have many entries for different applications. So these are just raw counts. Some of the things I look at here is the number of authorizations being done, and of course this W/P column, right? The number of times I'm waiting, and the high watermarks. You'll see how I'm going to use those here in a little bit. You'll notice that the command and pool statistics have the little asterisk that says that stats are being reset based upon your statistics interval. So they're reflective of whatever the current interval is. In my case, I've let it default to an hour, okay? The entries, the statistics are a running, ongoing thing, if you will. So DSNC is a transaction to Db2 commands, both to the interface, like this one's being done, and to Db2. However, set of statistics, dispatcher statistics now. Your typical CICS interval statistics or shutdown statistics, the summaries that you've done, depends upon how you process your SMF data. So again, we can see, right, the TCBs. Now, all the work of Db2 interface is being done on L8s, L9s. It's a task-related user exit or true, and that's where all the work is being done. So you can see current is 3, attached peak is 3, and of course the operating system waits has been 37, but again, we can see all the time. The operating system wait time, the total dispatch time, and so on, okay? And like any other CICS region, most of the time is obviously spent on the QR because we have not made a lot of our stuff thread safe. Well, I have, but in this case, I have not, okay? For good reasons. So basically, I can see the time being spent, right? And again, L8s, L9s would also include any thread safe applications or MQ. And that might be a good takeaway here, right? Looking at those things. It's not just Db2 on the L8s and L9s. It's going to be the MQ interface, and it's going to be your thread safe transactions. So in the same statistics, I have my Db2 statistics. So once again, a lot of information on us, information here. So we can see the region connection name. I have to define, and you'll see the resource coming up, a Db2 connection. CICS can only connect to a single Db2 at a time. Could I have multiple connections defined? Sure. But one and only one can be active. In this case, DB1A. My actual CICS resource name I keep is the same as the actual sysid for the Db2 region. In this case, DB1A. Group ID, blank. This is not a member of a data sharing group. We do run a little sysplex. We can do data sharing, but when I did this, I did not have, use any of the Db2 sharing regions. So that's why group is blank. It's just a standalone member. It's not a member of a sysplex, okay? It is version 11, as you can see. It is connected, okay? Standby mode reconnect basically says if CICS is up, if Db2 is not, it's going to wait until Db2 comes alive and connect, if you will. Plan name, I didn't make it up. My sysadmin, me, told me what to use. right? CICS PL is the plan we use for our CICS transactions that do Db2, okay? Db2 has to have a plan. Now, dynamic plan exit. Explain that a bit more when I show you the resource definitions, if you will. I do not have one in place, okay? But chances are, in the real world, you'll have one in place. Somebody's going to code that. That somebody is going to be a CICS system programmer, okay? Authorization type, user ID, pretty typical, okay? And of course, we're not doing a pool authorization ID. I don't want to have a fixed hard-coded user ID associated with a pool, okay? I could. Command thread auth ID kicks user. That's the default CICS user. And that's only because we do not sign on our regions. You know, we have a test system. This is not production. It's to teach classes. It's for my coworkers to play games, to try out different things. It's just a big test system, okay? I cannot afford to spend a lot of my time doing RACF stuff. So our CICS regions, we don't sign on. There really is no security going on. Hence, CICS user, because I did the DSNC transaction, right? And nobody was really logged on, so it's using the default user ID. The authorization ID, again, would show whoever last did essentially the DSNC command in the region, okay? Of course, the region is TCSSA3. Not going to talk about the create thread error, but you'll notice the transient data queue, CDB2. The interface is putting out messages, right, to signify errors or significant events to that transient data destination. Like most CICS transient data destinations, the C types that are being supplied by IBM, they're redirected to one of 3 different DD statements. The vast majority of them are going to the DD statement MSG USR, message user, or I think it's the CSSL destination that it actually uses. Purge time, or protected thread purge cycle time, 0.30, which is actually 30 minutes. Of the entries for Db2, okay? Pull thread wait setting, wait. In other words, I want the pull thread, if I don't have enough pull threads, we're gonna wait, as opposed to cancel the transaction and the user gets a nasty gram. Thread priority, more to come about that one. Notice it's equal. More to come about that when I get to the definitions. Current limit, 8. That is a parameter you'll see that you're going to set. Again, when I get to the resource definitions. Peak number of connections with Db2, 1. For the Db2, or the TCB rather, 1. Had I had my other coworkers doing transactions at the same time, doing Db2, it would be greater than 1. Okay, but the current number is 0 because at this point, when the statistics were done, there was no active transactions. Current task on the con ready queue, 0. If I had multiple systems people were doing DSNC transactions, chances are we would see them on a ready queue, okay? If 4 of us did DSNC transactions, 1 would be running, 3 would be on the ready queue. You'll see because I only have a thread limit of 1 for the connection, which is pretty good. More to come when I get to the resource definitions. Peak number of tasks on the ready queue, right? If you will, or the current and peak. What was the maximum number? Again, this is only going to be systems people doing Db2 commands, DSNC transactions, if you will. Okay, so that's pretty much the statistics, okay? There is a second part of that. Couldn't fit it on this slide. So now we see the pull thread limit, 3. How many pull threads do I have? 3. Current number, 0. Peak number, 0. Now those would actually be, if I've got things running on the pool, okay, those we would have numbers there. current number of tasks, peak number of tasks, and so on. Now, pull threads are any Db2 tasks or transactions doing Db2 that have not been explicitly covered by a particular Db2 entry. The problem I've got with that is on the right-hand side of the slide. Number of calls using pull threads. But notice, number of pull thread sign-ons, partial sign-ons, commits, aborts, creates, reuse, terminates. One of the biggest problems in doing things on the pull is it's going to do extra work. For every task that grabs a pull thread, the interface is checking, are you the same person that last used that thread? And if you're not, it's got to create, or at least at minimum do a sign-on on the thread, but more than likely terminate the thread, create a new thread, do the sign-on. It's going to do extra Db2 calls under the covers. Now this is all part of the interface, right? I remember I said it bounces back and forth a couple different times. It's all part of the interface doing that. So I'm actually doing far more overhead by doing the pulls. It does not maintain the identities, right? Unless it happens to grab, unless the application is the same exact application that used that thread the last time. What are the odds of that one if I've got 3 threads that I can work with? Not very good. Why I do not like pulls. Now I have seen a lot of people do pulls in their test regions. Let me toss a number to you, 5 to 8% overhead. Pretty much what I've seen in people's test regions. Now we're not talking my test region, which is very lightly, I'm talking about a typical corporate test region where the applications are doing, a fair amount of testing during the day, doing some, normal work, if you will. 5 to 8% extra overhead by using pull threads because of all the extra sign-ons or terminates or creates, etc., that have to go on. Okay? Hopefully you're nowhere near your 4-hour rolling averages. The very bottom part of that, you'll see the number of DSNC command calls, sign-ons, creates, terminates, and overflows. Because there's only, you're going to see one thread, you can see it there, command thread limit is 1. Last thing on the left-hand side. It's going to go through every time I do it. If I'm the only one doing DSNC, I don't have to worry about doing sign-ons. If I've got other people doing DSNCs, again, it says, is this thread the same ID as last used? I don't have to worry about doing sign-ons, right? If it's not, then we've got to terminate, create thread, and do the sign-on, right? It's got to authenticate. Is this person going to be allowed to do Db2 commands? So basically, extra overhead. You notice in my case, like I said, default user was CICS user. I'm avoiding the overhead because we're not signing on to CICS. But in the real world, as different systems people do the commands, we're going to go through the overhead, terminate, create, sign on. So that's why these numbers can be important to us. Okay, moving on. So Db2 entry. So I have one entry, THMZENT1 in this case. Plan name, okay. Dynamic plan exit, I don't have one. If you do entries, you're going to be doing entries based upon some collection of an application that's all related. So the need for a dynamic plan exit is not that great, okay? If, however, things are going through the pool, you're going to have a dynamic plan exit. And bear with me until I get the resource definitions. Okay, authorization type typical user, right? Thread weight setting for the entry is weight. You'll see an option to flop over to the pool. If I'm going to go to the trouble of creating a specific entry for an application, I do not want, right, when all threads are in use, I do not want to go to the pool because I don't want to have to go through plan selection, why I need a dynamic plan exit, and I don't want to go through the extra overhead of the create and threads and sign-ons and all that. I did an entry because I'm trying to save all that overhead. Again, we'll talk about priority being equal here in a moment. So how many threads for this application? 3. What's the peak number? 1. I was the only person. Notice, however, protected thread limit 1. So I have 3 threads in the entry. I have 1 that I have designated as protected. Remember, I was doing a cursor. So chances are my application is going to do a bunch of fetches. And again, the more data I have, the more fetches I'm going to do. If I've got applications doing a fair amount of work in Db2, CSS transactions, I really want a protected thread. And what that does is, as long as I do not hit the thread limits, whatever application gets the protected thread, okay, it's going to be held for that same application, same app, actual user, if you will, or internal user, use what they call unit of work ID, okay? So that it's like using that same thread for that high active application. That's why I want protected threads, okay? So that's, a good thing. Current number, and again, and a peak number, right, if you will. And I can change some of those things dynamically. Current number of Db2 entry tasks, 0. Of course, peak number was 1, and so on, okay? On the right-hand side of the slide, again, raw calls, right? How many calls were actually done to the entry? 7. These are the same things you saw when I did the DSNC display stat, right, essentially. So again, 1 thread create, 1 terminate, because I'm not doing a lot of work. And if I've got an entry for a given application, you're going to see far less thread creates, you'll see higher thread reuse, lower thread creates, lower terminates, and so on. Now, you saw a slide or 2 back, that purge limit. So here's a protected thread. If that protected thread is not used within 30 seconds, it's going to get freed up so somebody else can use it. The assumption is that application is not going to come back, so away I go, okay? So those are statistics, both that you can, if you have a monitor program, it's going to show you the same kind of thing. I can do a DSNC display. I can force statistics with the stat transaction, many different ways to look at those statistics, right? But they're coming out from SMF data in my case, okay? Or parts of the dump, you'll see. Okay, so let's get into the resource definition. So kind of a ho-hum slide, I just threw it in just to give you a picture. So as you're in the CICS region, your application does the Db2 call, right? It's going into the resource manager interface for Db2. You have TCBs, and again, you have the command, the pool, and the entry threads. Those are all the resources we're going to define. The true or task related user exit is the code that you saw me showing you in trace, that D2EX1, okay? And that's considered part of Db2, and it's off in the Db2 land at that point. Okay, we have to have plans, so it says Db2. You'll typically have, most sites will have 1 plan for each application. We're getting into packages. We should be in packages, I should say, for Db2 purposes, but plans are still necessary to kind of, pull everything into together, if you will, for statistical reporting purposes, things like that. So typically it's 1 plan per application, and they're unique. All right, so let's get into the meat. Let me check my time here. Got to get going here. Okay, so Db2 con, right? Resource definition. Now I can have many of these in CICS. I can only have 1 active at a time. That's the limitation. CICS can only talk to 1 Db2 region or 1 MQQ manager at any point in time. TCB limit, how many can I do? Now, I'm going to show you an SI parm coming up, okay? But I said I do not want Db2 to consume all of those. Maybe it's in the text. I take that back. It's probably in the text that you don't have. Max open TCBs, right, is a SI parm that you would code as a CSS systems person, and I have mine coded, I think, at 20. So what I'm telling Db2 here is I'm only going to allow 8 concurrent requests. I don't care if they're command, pull, or entries. There's only going to be 8 TCB threads at any point in time in the interface. The 9th one's going to wait, okay? And that allows, so you don't have all of the open TCBs being consumed by Db2. You know, the TCB limit cannot be equal to, or actually cannot be equal to or greater than the open TCBs, max open TCBs, okay? So we're kind of allowing other TCBs to be used for your thread-safe applications and MQ, okay? So that's why I picked the 8. Here you can see the purge cycle, 30 seconds, okay? How long it will keep the thread, protected threads active. COM auth ID, I've actually coded a CICS user because I don't sign on. And then my Db2 folks have done grants and revokes based upon that user ID, just like it would be sysadmin, and in my case. Command thread limit 1, I don't need more than 1 command thread. I doubt very seriously if there are 12 system programmers, if they're all going to be doing DSNC commands at the same time. Okay? Why you only need 1? Plan, again, my sysadmin gave me that plan. That's associated with this command thread primarily, and the pull initially. Thread limit 3, there's the pull threads, right? And I think the text on the bottom says 4, but it's actually, you know, slide is 3. I just mismatched between the 2 parameters. So that's the actual number of pull threads. So command thread 1, a thread limit here, pull threads of 3, counts for 4 potential, you know, concurrent use. Priority equal, default is priority high. What that basically says is all those TCBs that are part of the interface are higher in priority than the CICS ones. Chances are Db2 itself is a dispatching priority higher than CICS. Okay, and so is things like maybe TCP IP, RACF. You know, there are many other address spaces that are higher in dispatching priority than CICS itself, okay, even in a production environment. I really do not want some application. Remember I mentioned I had somebody that was doing 10 cursors? Boy, could I monopolize the CICS Db2 thread for a long period of time. If that happens to be in high priority, I could affect the whole region. Why I recommend priority of equal. The other choice is low, right? Probably never want to see the Db2 threads lower than CICS, but equal is fine by me. I really do not want poorly coded applications potentially hurting CICS processing. Yeah, just one way of minimizing some of that stuff, if you will, okay? So we do a connection, and that creates, in a sense, the threads limits for the command and pull. I do not have the plan exit here, okay? But if I'm using pull threads, I'm going to have to have a dynamic plan exit because it's going to have to figure out what plan to use. CICS PL is probably not good enough for every application running on the pull. In my case, it is because we don't do a lot of security. We don't do a lot of specialized processing. But whatever that plan is, that's the default plan for the pull. If I have different applications like human resources versus inventory, I'm going to have different plans. And I have to have a plan exit at that point. And again, I get into that more overhead. There's multiple slides that look the same, different text, and I'm just trying to remember what I told difference in the text. Oh, it's talking about the different options. So the rollback, right, is if you get -911s, -904s, we want the rollback to automatically occur Okay, so now to the entry. Okay, to the entry. So for every application, I'm going to have an entry. Important things. Plan. Now, in my case, it's the same, or it's kind of the same, CICS PL. Okay, how we're going to wait. Now, notice thread limit 2. I'm saying this particular application is never going to have more than 2 concurrent tasks making requests to Db2. However, one of them might be a heavy hitter, like cursor processing, doing lots of fetches. So I want a protected number of 1. So I get better thread reuse, right? I'm doing 1 thread entry, but I'm not holding. Thread wait, yes. So the third person, in this case, is going to wait. If both threads are in use and the application does, a third application comes in, it's going to wait. The other choice is to flop over to the pool. Well, you better have a good dynamic plan exit, and now you're going to pay the extra cost of all doing the extra commands to terminate, recreate threads, and sign on. Okay. Production region, 5 to 8% overhead could be very considerable. I've seen it be a huge number at some sites. What application? Any transaction that begins with THZ. Notice the Tran ID THZ asterisk. So I am allowed to use wildcards, right? The asterisk means any character doesn't care. A plus sign would be 1 character, but the asterisk, I could code something like T asterisk. So any transaction that begins with T would fit in this plan. The asterisk is multiple characters, don't care. I just did it in the 4th character of the Tran ID. But I could have done a plus sign. Plus sign says any character, don't care. Asterisk says multiple characters, don't care. Okay? You really want entries. You really want to have a good idea of how many are actually going to be doing Db2 work, thread limit. You can never, I can have 20 entries. I could have thread limits that add up to 40. Say every entry has 2, but I can never go higher than TCB limit because that's the limit for the whole interface. Okay, so this is per entry or per application. Okay, and again, protected threads are advisable for anything that's going to be a heavy hitter in Db2. Okay. Could I have more than 1 protected thread? Sure. Start looking at why you need more than 1. However, that says you got some pretty heavy work going on. Again, multiple slides to explain the parameters you'll see in the text. Now, if I cannot have a nice, tight pattern like THZ transactions, then we get into Db2 Tran Entries. Okay, and notice I basically said the entry is related back to THZENT1, but now this is trans ID THM plus sign. So I have a transaction that is not THZ, it's THM, and of course the plus sign here just to show you it's 1 character, don't care, it's a wildcard. I can have multiple Db2 Tran entries associated back to a given Db2 entry. And that's how I can get, if I don't have a pattern to my transaction IDs that are doing Db2, that's how I can get them associated with the same plan. And again, there's no threads here because their threads are associated with the actual entry itself, okay? So that's just the way, if I've got, a non-predictable pattern, THZ, THM, but they're all part of the same application, I can get them together, okay? IBM provides a sample plan exit. Doesn't do much. In fact, it does nothing, to be honest. I just give you enough information, where to go find it, etc. Some of the parameters it's passing, so you could put code in here. And this is the one IBM kind of ships. You put code in here to fit your needs, whatever that is. You're getting, user IDs, the application program name, things like that. You can say, well, I need to go human resources plan or inventory plan based upon that name. That exit name would be coded on the pool. Back on the Db2 con entry, you'd have a plan exit name. I didn't have one coded, so it didn't appear. Okay, quick look at data in the dump. So looking at Db2 SVC dump option 1, Db2 1, to basically show me the summary, if you will. Pretty much what you saw on the Db2 statistics display, what region I'm connected to, DB1A, what version it is, 11.1, what's my TCP limit, how many are, what's my current active connections, 1, all right, because did the command. Again, the transit data destination. Most important thing is a little summary at the bottom. THZY transaction number 300. The only thing that I care about is the lot address, life of task block, okay, and the entry name, RCT name, right? That tells me what entries this is associated with, and then a little correlation ID, ENTRTHZY0001. I hear Trevor trying to chime in.
Yeah, well, I was just going to give you a nudge about the time, if you could
Okay.
Speed it up a little,
I know.
please.
I will. I'm going to. I will speed it up, I promise. I'm almost to the point where I can just, say we're done. You'll see. Okay, what I care about here is this, and this would show up if I did the displays also, the thread displays. That if the lot address is a control block, right, that is documented, but most of the data areas in the Db2 portion of dump are not because they're a domain. The entry name is important because it's telling me what entry I've defined this in. And again, the correlation ID, if I've got to cancel the thread, I want to do it from CICS's point of view. And to cancel the thread, I need that correlation ID, okay? Now it's pretty straightforward. ENTR is entry, saying it's part of an entry, not the pool. THZY is a Tran ID, and then just a sequence number, 1. Is the TCB currently in Db2? Yes. So this point, when the dump was taken, that application was actually over in Db2 doing processing. Here's the lot. It is documented in the Db2 guide. There's also something called the C sub I don't care too much about, but the life of task block has some information in it. I don't have it documented. They're not documented anymore because supplementary data areas went away, but the basic format is documented for that. Okay. Dispatcher, very quickly. I'm getting the hook here. So dispatcher summary, notice there's 2 columns here, resource type, resource name. If I did a CEMTI-TA and display, you'll notice there's an H type and H value. Now this happens to be a CEMT transaction, but they're going to show up in that columns, if you will, resource type and resource name. So if they are my Db2 transactions involved, we're going to see information. Now I do have, let me skip ahead real quick here. I have my PDF on my other screen because I am trying to get to. I did give you some crude layout in the text you'll see for the lot and C sub and some other information. Again, you don't have the PDF yet. Okay, now I'm going to go through, these slides are going to look the same, but on the text that when you get the PDF, you're going to see some different weights, okay? Resource type, resource name are going to be why the tasks are waiting. There's probably at least a dozen different reasons why we'd have Db2 transactions waiting. Some are good, some are bad, really depends. So that is going to be all in the text. I'm not going to go through all that, but that's going to be all in the text, if you will. And again, there's like 3 slides that look the same because they have different weight conditions in dispatcher. So within dispatcher summary, I'm going to be able to tell why my application is waiting on behalf of Db2, as well as anything else. The comment I will make is all that stuff that's in the text is coming out of the CICS performance guide, okay? 5.4, I know they've changed it around, but it's coming out of the performance guide normally, and it is documented with a little bit of information. Be forewarned that there are other vendor products that may not have things well documented, but I can tell why I'm waiting. And it could be just I don't have a TCB, I'm on the ready queue, I'm not dispatchable, and I'm dispatchable, but I can't because somebody else is consuming the TCB. And there will be wait conditions that will tell me whether it's particularly to an entry or to a pool or I've hit the TCB limit. And that's all going to be in the text, you'll see. Okay? Almost done, I promise. Some other DSNC commands. Now, notice the -dis. Dash is saying I'm going to do the command over the Db2. So I'm saying, show me all the threads associated with this CSS region, TCSS-A3. I'm going to get a display that's going to go beyond the screen, okay? But I'm highlighting the status. I do give you the statuses you're going to see in the text, okay? I point out the entry here. Notice the ENTRTHZS001, so there's that thread ID that I can cancel by, okay? So this is actually displaying threads from Db2's point of view, right? But for this particular CICS region. This display can go beyond the screen, and the interface requires that you have BMS full paging, okay, for this to work. Now, most applications don't do that. So what I'm basically saying is this is being done by what's called page build and accum behind the scenes in the interface. So if I did a P/N in the upper left-hand corner, it's going to go to the next page. P/P would go to the first one, or previous one, I should say. Probably one you also want to jot down, I think I put it in the text, T/C, right? Tango/Charlie. That will get rid of all the pages that have been built up, okay? Could be many threads involved. Remember, I had 8. Display of a database on the next slide. Again, could be multiple pages, so you can page forward. So this is the status of a particular database. And again, you have to have the proper authority to do this. Mine are fairly small. Yours will go on for screen after screen after screen. TS is table space, IS is index. That should all be in the text. Status of read write. Right, says it's updatable, and then the AREO is IBM's new advisory reorgs, saying, we think you need to reorg this particular table, basically, is what it's saying. Again, your DBAs can help explain more of that stuff. Continuation, mine, again, I did the P/N to go to the next, so you can see here's the rest of it, right? So I see all the table spaces, all the indexes. The 1 through 4 means it's a partitioned table space, so I have a partitioned index, okay? Other commands, right? I can disconnect a plan, right? I can stop quiesce the interface, so I can start the interface. Now, the last 2 commands there are kind of nice. If I had more than one Db2 interface defined in the region, I can stop quiesce the current one. It will quiesce and disconnect when all applications are done, and I can start a different one, okay? So I can talk to multiples, but only one at a time. Cancel thread, and the token there is that token I showed you, ENTR whatever. And again, we can start and stop databases if you have proper authority. In other words, I can make databases go offline, I can make them read-only. You know, this access here is read-write. Now, these are actual Db2 commands, and I would have to have the proper authority to do that, but I can do it through the interface if I needed to. Basically done. I included all the CEDA screens. I went through the resource definitions. The resource definitions are meant to be done through the batch JCL, but here I have included the CEDA screens, if you will. So I'm basically done.
Brilliant. Thank you very much. That was great. That was wonderfully technical. Just the kind of thing we like in this user group. So, yeah, thank you very much for that. Let me quickly get control back. Okay, I'll just quickly run through the last couple of bits. News, we've got 2 things. CompuWare has enhanced Topaz for total test, and you've probably heard from many sources about CICS version 5.5. Articles, there have been rather a lot of those, and you can find all of them on our website. Zoom through those. Feedback requests, yes, give me your feedback about this meeting. This is a bit I do want to highlight. Next meeting is on the 5th of March, and we've got Ezreal Gross again, CEO of Circle Software. He's going to be talking about efficient management of online resources using CICS Configuration Manager. And the meeting after that is 14th of May, when we've got Tom back, and he's going to be doing another one of his in-depth talks about CICS and the MQ interface. So that'll be one to look out for as well. Okay, we're on social media. If you do tweet or anything, the hashtag is virtualCICS. Again, it's on our homepage, all these links. And that's about it. So thank you all for attending this meeting of the virtual CICS user group. I must thank Fundy Software, who have now been taken over by Rocket Software, who sponsor this user group and make these meetings possible. And of course, I'd particularly like to thank Tom Dunlap for his presentation. That's it. Thank you all very much for joining the meeting, and I look forward to seeing you on Tuesday, the 5th of March. So thank you all very much, and goodbye.